So something that you already know how to do before I talk about this, you don't need to write this down. But if I were just to say, find the value of sine 45, you would simply use your calculator. Okay. I asked you to find the cosine of 150. You use your calculator, etc., etc., etc. Okay. If I gave you an equation, so if I said, say, that the cosine of some angle x, or you call it theta, is equal to 1/2, well, you would find the angle x by doing the inverse cos. If I told you that the tan of x was 1, you would find x by taking the tan inverse of 1. We've done these, okay? Except now we're going to reach the point where we're going to be able to do all these questions without a calculator. Okay? There are certain angles, common angles that we use, that we don't need a calculator to find their trig ratios or solve equations. To do that, we need to learn about something called the unit circle, which is basically, unit means 1. So it's a circle that we put on a graph that has a radius of 1, but we'll see that in a second. Okay? Before we get into these, okay, we need to find some measures in a couple special triangles. Common angles that we use: 30 degrees, 45 degrees, 60 degrees, 90 degrees. And their multiples going past 90 degrees are common angles. I mean, if you look up here in the girders, those are all common angles. Okay, 60 degrees, 30 degrees, 45 degrees, which is commonly used in construction, commonly used in architecture. So in order to find the exact values of certain trig ratios, or the trig of certain angles, we need to first make some triangles. So here is an isosceles right triangle. If a triangle is isosceles, that means that two of its sides are the same. If it's an isosceles right triangle, that means two of its sides are the same and the other side must be 90 degrees to be a right triangle. Well, if this is 90, these two must add up to 90 because all three must add up to 180, so each one must be 45. This is what a right triangle with 45-degree angles, acute angles, looks like. So just for ease, I'm going to call the legs 1 and 1. Okay, because they're the same, because these two angles are the same. But I'm missing a side. How would you find this side? It's a right triangle. You know two of the sides? Pythagoras, right? This is the hypotenuse. So to find the length of this side, okay, we're going to go a squared plus b squared equals c squared, where a and b are the legs. Well, in this case, a is 1, b is 1, and c I'm just going to call the hypotenuse squared. So we figure out what the hypotenuse is. 1 squared plus 1 squared is 2. That is equal to the hypotenuse squared. So therefore, the hypotenuse is going to be the positive and negative square root of 2, but we just write positive because it's a hypotenuse. And don't use a calculator. Okay? We want exact values. We've been working with those this year. So that means if I have a right triangle that has 45, 45, and 90-degree angles in it, and if I call the legs 1, the hypotenuse must be the square root of 2. Okay? So I'm just going to redraw that. I'm going to redraw it the other way, facing the other way. So we've got this. We've got 45 degrees, 45 degrees. The third angle is 90 degrees. We were told that the two legs were 1. And we figured out by Pythagoras that the hypotenuse was the square root of 2. Okay? The reason I'm doing this is I want to put this triangle on a coordinate grid that you'll see in a second. But the way I want to put it in I want a triangle where this is 1. So how do I convert from this to this? Well, this is proportionally smaller than this. So what would you divide this by to get 1? Root 2. Root 2 divide root 2 is 1. Well, if you're going to divide that side by root 2 to make it proportionally smaller and have a hypotenuse of 1, you got to do the same thing to the other sides. And what's 1 divided by root 2? Well, we can't divide it cleanly. So we leave it as 1 over root 2. But in the first unit, when we did radicals, I told you guys, well, really, we shouldn't have radicals in the denominator. So this is not looking proper. Do you remember how to get rid of the radical in the denominator? We multiply it by something. What would you multiply it by? Yeah, by the radical. So that's going to give us up top the square root of 2, and root 2 times root 2 is the square root of 4, which is 2, no more radical. And this side would be the exact same thing, because remember, those two sides were both 1 in the triangle we started with. So if I create a 45, 45, 90 right triangle, and I call the hypotenuse 1, the legs must be that length. Must be. And we've proven it mathematically. Okay? So that's for 45-degree angles. What about 30 and 60-degree angles, the other common ones? Well, we use another right triangle. This time, though, what I'm going to start with is an equilateral triangle. Remember, in an equilateral triangle, all the sides are the same length and all the angles are the same measure. So in any equilateral triangle, the 3 angles that add up to 180 must be the same measure. So therefore, all 3 angles must be 180 divided by 3, which is 60. The reason I did that is because I want to see what's happening at 60 degrees in a right triangle. Well, if I take this equilateral triangle and cut it in half, like so, I actually create a right triangle where one of the angles is 60 and the other one must be 30 because it's half of 60 up top. That's the triangle I want. I want to know 30 and 60. It just so happens that they are both in the same right triangle, which makes sense because 30 plus 60 plus 90 is 180. If I create the blue one from the equilateral, what would this length be? What's this length? What's this length if it's an equilateral triangle? 2. So therefore, this would be 1. And focus on the blue right triangle. What would this length be? Well, I have to use Pythagoras. So this time it's a leg that I'm finding. So again, using Pythagoras, a squared plus b squared equals c squared. One of the legs I don't know, so I'm going to call it leg squared. The other leg is how long? 1. And the hypotenuse is how long? 2. So to figure out what the leg is, the leg squared plus 1 will equal 4. Subtract both sides by 1, the leg squared will equal 3. Therefore, the leg is going to be the plus and minus square root of 3, but we don't use minus. So it's going to be root 3. And again, don't go to decimal. Leave it exactly. As soon as you punch it into your calculator and estimate, you're rounding it. You're no longer stating it exactly. Okay, so just like we did with the one on the other page, I'm just going to turn it around facing the other way. So this would be 30 degrees. This would be 60 degrees. This is 90 degrees. This is 2. This is 1. And we figured this out to be root 3. But I want a hypotenuse of 1 to be able to put it on a grid. Yeah, I'll use blue. I want a hypotenuse of 1. So I need to make it proportionally smaller. What do I divide by to get from 2 to 1? 2 divided by what is 1? So I got to divide all the sides by 2 to get a hypotenuse of 1. Root 3 divided by 2 is just root 3 over 2. Leave it at that. 1 divided by 2 is just 1 over 2, or 1/2. So these are the triangles I want to focus on. What we did is we created right triangles, 2 right triangles, where both the acute angles were 45. And then we created another one where the acute angles were 30 and 60. And in both of those, we converted them so they had the hypotenuse of 1. So keep in mind these triangles here that we ended up with, because we're going to put those on a coordinate grid. We're going to put these in, and I'll show you how. Okay, we're going to use something called a unit circle that we're going to put those triangles we just found into. What is a unit circle? A unit circle, well, the word unit means 1, so it has a radius of 1, and its center on a coordinate grid is at the origin. Okay, so if I draw a triangle, if I draw a right triangle on the unit circle, remember the hypotenuse comes from the origin to the circle, well, that's 1, because it has a radius of 1. Finish the right triangle in quadrant 1, well, this length is going to be whatever the value of x is at this point. And this vertical length is going to be whatever the value of y is. Remember those two triangles we created? We made the hypotenuse 1, right? So I can take those triangles and now fit them into the unit circle. Let's take the 45-degree triangle. Remember that blue one we found, or that blue one we made? Well, 45 degree, if the angle coming out of the center is 45 degrees, the other acute angle is 45 degrees. Remember the hypotenuse we made to be 1. What were the sides again? No, 2. Root 2 over 2. Root 2 over 2. So I took that triangle we created on the first page and I just put it in the unit circle. That means I can find the point on the unit circle. What's this point? Well, x value is root 2 over 2. Y value is root 2 over 2. So that's the point. Again, this is all setting up to be able to do the trig. What about the 30, 60, 90 triangle? Well, there's two ways you could put it in. You could put it in so that the 30-degree angle is coming out from the origin, or you could put it in so that the 60-degree angle is coming out. So if we put it in, we did the one that looked like this first, where this was 60, this was 30, the hypotenuse was 1, because we converted it. Do you remember the sides? The shorter side was 1/2, and the longer side was root 3 over 2. Because the square root of 3 over 2 is longer than 1 over 2, because the square root of 3 is bigger than the square root of 1. So the point on the unit circle, when I put the 30, 60, 90 triangle in like this, the x value is 1/2, the y value is root 3 over 2. What if I put it down and insert it so that I get the 30-degree angle? It's still the same triangle as this, I've just manipulated it. So the 60-degree angle would be here. This is still 1, but what's this side? Root 3 over 2. And what's this side? 1/2. So therefore, the point, it's the same values, except I reverse the numbers, or I reverse the values. So what does all that mean? All that means is that when I put a 45-degree angle into the unit circle, the point that it hits will be root 2 over 2, comma, root 2 over 2. If I put a 30-degree angle in, the angle, or the point that it hits on the unit circle is root 3 over 2, comma, 1/2. If I put a 60-degree angle in, the point that it hits on the unit circle is 1/2, comma, root 3 over 2. What happens if we put 0 and 90 in? Well, wouldn't a 0-degree angle both arms would be like that, right? Because it's 0 degrees. That means both arms are the same. It doesn't go up at all. So I've actually drawn two arms here. And remember, this length is 1. What's this point? If this length is 1, what's this coordinate? You need two values.
0 and 1.
Nope. 1 comma 0. So that means at 0 degrees, the point that it hits the unit circle is 1 comma 0. What about at 90 degrees? Well, doesn't it go up? Here? That's 90 degrees? No. It's not 9. No.
0,
0 comma 1. Okay. Because at 0 degree, like that's just looking at the coordinate grid. If it's 0 degrees, it's right flat, so it goes to the point 1, 0. If it's 90 degrees, it's a quarter up, so it goes up to 0, 1 on the unit circle. So we found 5 values from those last 3 diagrams. We found 0 degrees, 30 degrees, 45, 60, and 90. We just did 0 and 90. Remember, the point on the unit circle, if the angle is 0 degrees, is 1 comma 0. If it's 90 degrees, then it goes a quarter up to 0 comma 1. What was 30 degrees? What was the point? Root 3 over 2 comma 1/2. 45 degrees, what was the point? This one's easier because the values are the same. And 60 is related to 30 because we take the values from 30 and flip them. Okay. Now what about more angles? You're gonna, no. It's actually good. So what I'm gonna do, and what I usually end up doing every year, is I always put these in, but I end up not using them. I actually end up going here. So go to this page. This is where you definitely want to use different colors. 4. You got 4? It's good. Okay. These are all the angles you're going to know the points to. You already know 5 of them. You know these 5 right here. Because remember, this is 0, and this is 90. No, that's why I said have different colors. What's the point on the unit circle at 0?
1, 0, 1, 0.
1, 0.
Oh.
What was 90?
This one is 0 and 1.
0 comma 1. Let's keep going the multiples of 90. So if I go 0, then 90, the next one add 90, let's go to 180. What would be the point at 180 degrees? Come on, you guys. Points have 2 values. Negative 1, 0. What if we went 3/4 of the way around? What angle is that? What angle is that? It's not 360.
270.
270. What's the point on the unit circle?
0, -1.
Correct. And let's go all the way back around where we started. So not only is it 0 degrees, it's also 360.
Wow.
So two angles have a point at 1, 0. 0 degrees, and if you go all the way around, 360. Okay, so we've just added more angles. You guys now know the points for 180, 270, and 360. Let's do 45. 45 comes out in the middle here in quadrant 1. That's 45 degrees. What was the point on the unit circle?
You know. √2/2.
Continue.
√2/2.
What if we found its friend or family member in quadrant 2? It would go out in the middle of quadrant 2. What's that angle? Think about it. 135 degrees, because it's 90 and then another 45. Or if you think of your reference angles, it's 180 minus 45.
That would be
What do you think?
negative.
Both negative?
No, the second one would be positive.
Second one would be positive. What if we found its family member in quadrant 3? Goes out in the middle. What's that measure? 225, because you go 180 and then another 45. So it's 225. It's going to have the same values as the other ones in the family, except this time, and the x value. Both of them are going to be negative.
Now this one is just going to be negative, right?
Hang on. Here's our one in quadrant 4. What's that? Where am I? Oh,
Crazy.
what's this angle? 315, because if you think about it, you can do it a couple of ways. You go all the way around 360, but then subtract 45. Or you can think of it that you're going around 270 and adding another 45. What's this one? Correct. Next one really doesn't matter which one we do, so I'm going to start with this one. What's that angle? 30 degrees. What was its point on the unit circle that we found by inserting that 30, 60, 90 into the unit circle? Ooh, yeah. √3/2, comma 1/2. Its family members in quadrants 2, 3, and 4 will have the same values, except one will be positive, or both will be positive. Well, hang on, let's get the angle first. Not 120. Think of it this way. We're going 180 to here and then less 30. One what? What's 180 minus 30? 150 degrees. What's the point on the unit circle?
-3/2, 1/2.
Let's go to its family member in quadrant 3, which would be what angle measure? 180 halfway around, then another 30. Anyway, 180 around, another 30. 210. What's its point? And -1/2. And if we find its family member into quadrant 4, what angle is that? Think of it, you go all the way around to 360, less 30. 330 degrees. What's its point?
-1/2.
Almost done, we just need the 60-degree angles. The family of 60. So we know this is 60 here.
So this is going to be 1/2 and 3/2.
Right. Its family member goes up high in quadrant 2, and it would have a measure of, think of it, halfway around is 180 less 60. 120. What's its point on the unit circle? Ugh, missed that one. Let's try that again. What's that angle? 240, because it's 180 and then 60. And what's its corresponding point? And finally, 300.
1/2 negative.
Good. So we started out with 5 angles in quadrant 1 from 0, 0, 30, 45, 60, and 90. And now we're at 16 angles. Actually, 17 angles. This you want to keep safe, because not only do we use this year, it's big next year. Okay. So the reason I don't think they even do the unit circle in grade 11, but I always do because it helps for grade 12. Okay. So the question is, you're going to have to commit these to memory. Yes, you're not going to be able to use this. What you're going to get, what I'm going to give you, on an assessment, I'm going to give you this. It's blank. This is what you would get on the grade 12 exam next year. So you have to know the angles that go in. So we have to look for patterns. Okay? Everybody sees things differently. Okay? Like if you notice, the values here, there's only 3 different values, aren't there? Root 2/2, 1/2, and root 3/2. Okay? And yes, the ones on the axes also. But those should be pretty easy to remember, those ones. Okay, because the ones that are on the axes are either going to have a 0, a 1, or a -1 as the coordinate. Okay? Remember the 45 ones, the ones that come out in the middle, those 2 values are the same. Some people remember it like that. And then they commit these. If you look at different patterns, some people look at it and say, well, if I go 30, 45, 60, all the denominators are 2, always. But notice this goes root 3, then root 2, and technically this is root 1. So we go root 3, root 2, root 1, root 1, root 2, root 3. Some people remember it that way. Okay? I mean, you can put your hand on it. Remember it from your hand. There's different ways. I don't really suggest any way. I just suggest that you find the easiest way to remember it. Some people remember it by a song. Okay, I'm sure you could find a song. So that's the big thing. So I'm going to give you until 10:30 to look at this unit circle. Then you're going to have to put it away and answer some questions I give.
Got it.
Just see what you can do.
Hey, yo.